Thank you all for joining. This session is being recorded. The session in question is 4A0 and it's developing and deploying Java EE and Spring Boot applications for CICS. We're joined today by Phil Wakelin, who's our Java adoption specialist in CICS development down in Hursley. And we also have a special guest appearance by Mr. Rob Stroud towards the end of it. So with that, please give us your feedback. You see the QR code there on the bottom left there. I expect it will also be at the end of Phil's presentation. But with that, I'll hand over to Phil, who will take you through Java on IBM Z. Cheers, Phil.
Okay, thanks, Nick, and good afternoon, everyone. So this session is all about Java EE and Spring Boot. So Liberty in CICS has become very popular, and we've got a lot of customers now using Liberty in CICS. And Java EE has been the traditional way of developing applications in Liberty, and we're going to have a look at Java Enterprise Edition. But then we're also going to have a look at Spring Boot, and Spring Boot has become very popular as a development paradigm that's kind of builds on Java EE, provides somewhat an alternative to Java EE, and look at some of the differences and benefits of using that and how that works, deploying that into CICS. Also looking at Maven Central, Maven and Gradle build systems, which are all kind of mixed up with this Spring Boot development paradigm. So first, I just wanted to introduce CICS as the mixed language application server. And this was a branding we did in version 5.4 that was really focusing on the multi-language, the mixed language capabilities of CICS. So not just the traditional languages of COBOL, C, PL1, assembler, but now we have Java and Java Enterprise Edition, and of course Node.js as a powerful way of modernizing applications, enabling mixed language applications with components that can comprise any of those language modules all intermixed in the same CICS region, and all sharing the same CICS security, transaction, and task scheduling context that we all know and love. So here's a quick picture of how Liberty in CICS kind of fits together. So we have Java applications that are deployed into Liberty, and they have APIs available to them. And we have a wide range of APIs, of course, with Java EE and of course with Spring Boot, but we also have some system level functions. So we have JCICS, which you may know about, which are the Java wrappers to the CICS APIs. We have JDBC, which are wrappers to DB2 SQL. We have JMS, the Java Messaging Services, which is a wrapper which allows you to access IBM MQ. We have our own JCA resource adapter, which is essentially a wrapper to a link to allow you to access COBOL applications using the JCA paradigm as popularized by the CICS Transaction Gateway. And then we have the JSOS APIs, which are actually part of the Java SDK on Z, which enable you to access ZOS services such as file and console and so on. So lots of facilities to choose from. So this is a high-level view of how Liberty in CICS functions at the architectural level. So we have listeners, principally a HTTP listener that have with its own threads, and they allocate threads from a Liberty thread pool. And then we have our own CICS thread factory implementation, which augments the default thread factory that Liberty provides, and provides a set of CICS-enabled threads, which are created inside our thread factory. They're dubbed with a CICS TCB, the T8 TCB, and they're made available to the Liberty thread pool. Transactions are run on those, replies are sent out, and all that happens within the Liberty server. Now, we can also have MDBs being processed as well as HTTPs. MDBs are meshes-driven beans from MQ. You can have other JCA inbound adapters, so you could develop your own inbound adapters using JCA inbound, very similar to MDBs, or you could have IIOP requests from remote EJBs all coming in. But principally, most customers are using HTTP for sort of Java-based web service solutions. And of course, we have other threads inside the JVM which are managed through the JVM internal work, the GC and the JIT and so on, but they're outside of the control of this thread factory. So that's just a high-level view of how Liberty works in CICS. So let's have a look at Java Enterprise Edition. So Java EE has a somewhat long and rich history. Our support in Liberty started out with Java EE6. So the first versions of Liberty and CICS supported Java EE6, the web profile, and it's moved through Java E7, 8, also embracing the Eclipse micro profile as a sort of subset of Java EE for microservices, and then evolving into Eclipse Jakarta EE8, EE8 and EE9. So Jakarta is a transition of the Oracle-based Java EE to the Eclipse Foundation. So Java EE8 and Jakarta EE8 are synonymous. So that was a naming change. And then we're moving towards Jakarta EE9, which is a transition to a new package namespace. So we get Java package name changes and somewhat paring down of the platform. And that is already in beta support in Liberty and is something we're looking to support in CICS as we move forwards. So in Liberty, functionality, Java EE functionality is made available through features, and they support components of Java EE known as JSRs. And this is the list of Java EE7 features that Liberty supports. And you can see we have a profile called the web profile, which is just a subset of the full platform. And the full platform includes a variety of other things like Batch, EJB, JCA, and so on, JAXB, in addition to the web components, which are the lighter weight web-based components, such as servlets, JSPs, JSF, WebSockets, the popular web technologies, and the enablers for those. So very easy to configure and very pluggable. Each of these can be configured, and Liberty will manage the dependencies between the components, and will tell you if you've got it wrong if you choose components from different versions of Java EE, for instance. So if you look at Java EE web profile, we have the sort of core web technology, servlets and JSPs. We have the RESTful JSON-based web services like JAX-RS, which is very popular nowadays for creating APIs and API enablement. We have local EJB support in there as well for local EJBs. We have a context and dependency injection, which is a popular way of doing dependency injection with a lighter weight version of EJB. And we have the new web sockets, sort of bidirectional socket capability available as well. So they're the core bits. If you look at the full profile, we've got this business application tier and the enterprise access tier. So your business applications will be able to use the full EJB, CDI managed beans, and the whole of Java Web Services. And then at the enterprise access tier, there's a set of technologies available for accessing the enterprise. Of course, JDBC is very popular, and in CICS, that's wired into the DB2 adapter with type 2 connectivity, and we have type 4 connectivity available as well. JPA is a persistence architecture that's built on top of a database access. It's a bit like entity beans were in the old EJB specification. We have JTA, which is a transactional architecture. So it's a Java transactional API for managing transactions across resource managers, such as JDBC and JMS, for instance, would be two resource managers that it could manage. It can also manage the CICS unit of work as well. And we've done work to integrate and the CICS unit work with the JTA support if that's required. JCA is the Java connector architecture used for connecting to enterprise systems. And as I say, we have our own CICS JCA adapter available, which encapsulates a link. And then there's this new Java batch technology, often known by its JSR as JSR 352. That's a specification number. And that's for running batch style workloads in an online environment. And we'll look at that at a high level to see how that works in a bit. So what can you do in the different levels of CICS? So we look at 5.3 onwards, we see we've got web profile available in the early versions with Java EE 6. That continues to be supported. With Java EE 7, we supported full profile through continuous delivery with this APAR available. That came available in 5.3, was available in 5.4 in the base. And then with Java EE 8, we got full profile available with this continuous delivery APAR. And we also support Jakarta 8 in version 5.6 for in full profile. So we've got a variety of options there available to you, depending on which version of Java EE support you're looking for. A note here is that Java EE 8 or later does not support OSGI applications packaged within EBAs. So an EBA is an enterprise business archive, I think, and it's a way of packaging an OSGI style application in an archive that Liberty supports. So we support these OSGI applications in Liberty. However, Liberty do not support that in Java EE 8 or later. You can still use OSGI packaged applications in a CICS OSGI JVM server, and that's fully supported, remains supported. It's just has fallen out of support in the Java EE environment. And we see most applications using WARs, which are the non-OSGI packaged way of deploying applications with Java EE. So just a step back, and then just a quick look at the basic technology. So what a lot of people start out doing is a basic servlet technology with a JSP. So you have your browser, sends a request to a servlet, builds a data object, pass that to the JSP. The JSP does the HTML, so it builds the HTML with the request from the servlet and sends that back to the browser. And here we can see a little servlet sending its request to the JSP. The JSP contains the HTML that's going to do the display logic and then forwards that back to the browser. So a lot of customers start out with servlets and JSPs. Now, next step on from that is the full Java EE environment. And you can see with Java EE, we've got a highly componentized layer with presentation layer, business layer, and the database layer. We've got the JPA support. With the JPA engine, entity beans were available in the old version of EJB, but now we've got JPA support. EJBs, you can have session beans and message-driven beans. Java clients can communicate with those, or quite popular to have servlets directly talking to session beans. So full support for the Liberty EJB support is available in CICS if you're invested in EJB. JAX-RS is another very popular technology. We see a lot of customers now starting out with JAX-RS, creating a RESTful service with this JAX-RS Java EE API. And here we've got a RESTful service using these JAX-RS annotations. And we have this path annotation on our class myService. So that says that we're going to use the URL myService. And here we are. My application is called my application, and we've named the path myService. And then we've got these path elements. We've got get widgets, and we've got the get widgets path element here. And that's going to allow us to specify some inputs such as from equals 5, 2 equals 10. We've got some query parameters here to look for some inputs on this get widgets. And then we can process our get widgets application build some response and send it back. And that's a very, very simple JAX-RS RESTful based application. Typically, you'd be building a JSON request to return back to your API client here. So, but you can also build XML, of course, and HTML or binary, so you can have all sorts of formats sent back using JAX-RS. Now, I did mention Java Batch with JSR 352. So Java Batch enables you to build a very sophisticated batch processing engine or infrastructure within the Liberty and within the CICS environment. So this is a typical environment you could build. So you typically have your CICS regions running as executors accessing data, the DB2 or vSOM data, and they'd be running CICS programs to do that. And then you can also create a dispatcher, and a dispatcher would use a messaging engine to interact with these executors. So we've got a queue of work processed in the messaging engine, and the dispatcher would be fed from either a REST connector, or it can use the WOLA connector, and you've got this batch manager clients, and we have the Tivoli batch manager support that integrates into this, so you can use the built-in Tivoli batch manager support for this. You can also run all this in a single CICS region if you wanted, or you can break these out into different Liberty servers running in different components like so. So a powerful infrastructure for modernizing batch using the CICS runtime environment. So lastly, I should mention that the CICS Explorer SDK. Now, the CICS Explorer SDK has been around for at least a decade now, and is an Eclipse plugin and supports Java EE and Jakarta EE and Liberty, and is a tool widely used in Eclipse on a workstation. You install the Explorer SDK into your workstation, and you create this CICS bundle project, and you can have a web project, and it enables you to then export the archives. So it'll be the CICS bundle project that's exported, and would include a WAR file for a web application, which can be then installed into the CICS region using a bundle definition. That's been around for a while, still supported, and supports all the latest levels of Java EE. So if you're using CICS Explorer, one of the things you do need to be careful about is compatibility. So the Aqua version is essentially the sort of Eclipse software stack version that IBM supplies, and there's different versions of Aqua. And then Eclipse itself has different versions. So the 3.2 Aqua is the latest stack of our Eclipse tools, and that's compatible with Eclipse Photon version 4.8. And if you go to our download site, it tells you the different levels of Aqua and the different installation methods. You can install that through the IBM Installation Manager or directly into Eclipse with the P2 method. So quite a few choices there for installing the CICS Explorer. But that's all pretty well documented, and I expect a lot of you who use Java are quite familiar with that CICS Explorer methodology. There are more modern ways of doing this, and we'll look at that as we go forwards, but I just wanted to run through what we've got at the moment. Now, if you are interested in Java EE, we do have 3 CICS-centric samples that I wanted to point out. We've got a basic Hello World servlet in the CICS Explorer samples. If you do a new project and look for CICS examples, you'll find this CICS Hello World sample, which is a simple servlet that you can run, deploy inside CICS. Very easy to use. Then we have a more sophisticated sample on our GitHub. So we have a lot of samples now on our public GitHub CICS dev community called the Simple Web Shop. So that's written by Alex, one of the developers in the Modern Languages team, and it shows you how to use local EJBs in Liberty, a nice little shopping example. Also, we have a DB2 based sample called the employee sample that's also available on GitHub, and that uses both JSF for its presentation logic, and it obviously accesses DB2 using JDBC. So a good example for using either JSF or JDBC. Now, we promised to talk about Spring Boot, didn't we? So Spring Boot, what's that? So Spring Boot is an open source project run by Pivotal, and its aim is to make it easy to create standalone production grade Spring-based applications that you can just run. So that's the tagline, just run. So it's a simplified programming model that enables you to just drop applications into the runtime, very much focused on the containerized model so that every application contains all its dependencies packaged inside the application. It was primarily designed to simplify Java EE using POJOs and based on dependency injection. So there's a lot of annotations. So you really need to understand the annotation processing to understand the power of Spring. So what have we got in the way of Spring Boot support? So we've got support available for all the key Spring Boot concepts. So we have support for Spring Transactions, the Spring Task Executor, which is a way of scheduling tasks. We have support for Spring Security, which is a security API. And we also support a Spring support for JDBC and JMS through their data source support. And we have support for our own CICS API, all available in Spring. Liberty provides 2 features to support Spring, the Spring Boot features. However, these are only required for Spring Boot applications in a jar. And typically, most customers would use scenario 1 here, which is a servlet in a WAR. It's very simple to create a Spring Boot servlet in a WAR, and you can deploy as many of those inside Liberty as you want. Standalone Spring Boot web applications are packaged in a jar and are designed originally to run standalone and have their own inbuilt server, like a Tomcat server. You can run those inside Liberty, but you can only deploy one jar at a time. So we see most customers using scenario 1 or scenario 3. And with scenario 3 here, we support a link to POJOs and Spring Beans in a WAR. So that's the link to Liberty function. We've developed our own annotation, the CICS program annotation. You can add that to a method in your Java program, and then you can just link to that Java program from your COBOL. And that is supported in version 5.5 onwards with corresponding updates in the CICS Explorer 5505, because that requires support for this new annotation processor. There's a lot of function involved in this CICS program annotation that we created. So here's a sort of simplified view of a Spring Boot application. So you have 3 main components. So you have the application class with a main method that runs the Spring application. And here we are, we can see we're invoking run on Spring application, passing in the application class. Then we have the servlet initializers. So this is generated code, the servlet initializers. And that generated code extends the Spring Boot servlet initializer, which is the Spring Boot initialization component, and uses a Spring application builder to register the class as a configuration class of the Spring Boot application, enabling you to package your application as a WAR. So there's a large amount of work done in the servlet initializers in the Spring Boot, but all the bootstrapping goes on through this servlet initializer component, and that all the annotation scanning. So and we can see here we've got annotation Spring Boot application and REST controllers, and it's these annotations that provide all the power for Spring Boot. Then you'd have, typically, if you're building a a RESTful API in Spring, you'd have a set of REST controllers. So here we've got a class my controller, and we're saying we're creating a mapping, a URL called browse, and it's going to be a browse method, and it's going to take some input parameters, and we're going to look for the value input, and then we're going to do something with this. So we're creating an API here, a browse API that's going to take some input and do something. And you typically have several REST controllers in your application to handle your REST endpoints. So that's a very simple view of a Spring Boot application. Now we have a full set of tutorials, and we've 5-part tutorial series, and that is published on the new developer.ibm website. So we've now moved all our development tutorials away from DeveloperWorks to developer.ibm.com. Here's a screenshot of part 1 covering CICS and then Gradle and Maven builds. And then we've got more in-depth tutorials looking at security, transactions, JDBC and JMS. And we have all the sample code available in our GitHub. And we have a few extra samples as well covering link to Liberty and async and so on. So a lot of samples there with Spring Boot. It's the kind of environment where you it's very useful to have tutorials and transaction samples, and we've spent a lot of time creating some excellent material for you. So moving on to developer experience. Developer experience has been a focus for the CICS development team over the last couple of releases. And we have a developer experience team which have been providing a set of enhancements. Now, one of the first things we did for developer experience was supporting Maven and Gradle build systems. So the issue here is that with Spring Boot, if you remember, I said that each Spring Boot application is packaged as a standalone component. That means it contains all the Spring Boot infrastructure it needs to run itself. And that means the deploy components can be quite large. Typically, at least 20 meg for a hello world, easily be 50 meg for larger applications. And they're pulling in a large number of open source libraries. And these open source libraries are versioned, of course, and managed. Now, you could install all the dependencies into your Eclipse environment. Sorry about that. You could install all the dependencies into your Eclipse environment. However, that would be a very onerous task to do. So what we've focused on is support for Maven and Gradle. So Maven and Gradle are build environments that allow you to automate this build. And they essentially solve the problem of having to install the kitchen sink into your Eclipse environment. So the key part of this is Maven Central, which is an open source library system. So if you go to search maven.org, you'll find all the libraries available on Maven Central. And we've got our CICS libraries available here. There's the Spring Boot libraries, there's Java EE libraries, JDBC, JMS libraries, MQ libraries, all the major components you might need are available on Maven Central. With CICS, we have a bill of materials. So this is a bill of materials is essentially a descriptor about a set of artifacts which have dependencies. So we provide a bill of materials for different releases of our API. And when you use the bill of materials, you don't need to worry about versioning the API, making sure you've got the right level of the different parts of the API. So we've got an article that explains about the versioning of CICS in Maven Central if you want to look further into Maven Central versioning. These are the different artifacts you would find belonging to CICS in Maven Central. So as I say, we have the bill of materials, which is called the BOM. You have the CICS API. Then we have our new API, CICS-X, which is a new remotable API we'll talk about at the end. Then we have the annotation processor and then the annotation support for link to Liberty. And that's the CICS program annotation. And if we produce any more annotations, they will go into this package. The actual annotation processor itself is the code that processes the annotations. And then we have this CICS Bundle Maven plugin, which is a plugin to build CICS bundles as a sort of optional way of building your bundles. And we'll have a look at that later if we've got time. So quite a few components to choose from, and you can choose which ones you want. Typically, you'd probably want bill of materials and CICS API, and then you may want link to Liberty if you're using link to Liberty. So comparing Gradle and Maven as automation tools. So this is separate to Maven Central, which is a repository. We've got Gradle and Maven as two tools, which are open source build automation tools. We've got Gradle, who's famous for its little elephant, and we've got Maven as part of the Apache Foundation. Gradle is a very flexible Java-based build system with a Groovy style syntax, whereas Maven is based around this POM model with the project object model, integrates, of course, with Maven Central with an XML-based syntax. Here's a little look at Maven architecture. So just using Maven as an example. So you'd have your build file, your POM XML, and that's the code artifact, you might call it, that describes the build. The manager reads that and pulls in plugins and dependencies, project information from repositories such as Maven Central, and then drives a plugin, and the plugins will compile, and you can also run tests and install processes as well as part of this build pipeline. So here's some snippets from a Maven POM. So here we can see we have the bill of materials. So this is the bill of materials, the COM IBM CICS TS BOM. It's versioned according to the version of CICS, the build stamp, and then the APAR number of the CICS, JCICS APAR. And it sets the scope that is then used in the dependencies. So this scope import is important. And then you would have a dependency here, which is the COM IBM CICS server, the JCICS API. That is the dependency for JCICS and uses this scope specified here in the BOM. So that's a simplified bit of POM XML. Here's a Gradle build file, which does the same thing. So in the Gradle build file, you're using this more natural language syntax. So you define plugins. So here we have some plugins. So we've got a Spring plugin, Java plugin, Eclipse plugin, IDE plugin, and a WAR plugin. So they're all the bits we're going to use. We're going to name our build and talk about the source compatibility with Java. Then we're going to say where the where our source can be found. So Maven Central we're going to use as our repository. Oops. I'm sorry, we just managed to jump a lot of pages. And then we're going to look at dependencies. And here we have the actual dependencies. So we're going to say we're going to use Spring Boot, the Spring Boot web package. So we name the Spring Boot web package. We're going to name a dependency on the Spring Boot starter Tomcat, but we don't want to include it in the build because we don't need Tomcat in the runtime because Liberty will provide our Java EE. So that's we use a different statement here rather than implementation. And then we have compile only statements. And here we're going to set the enforce platform, which is the bill of materials. And then we're going to compile this with the JCICS API. We say compile only rather than implementation because CICS provides the JCICS API. So we don't need implementation, we just need compile support for it. So these are the sort of statements you see in your build files. And they both, Maven and Gradle build systems can be used to the same effect. So lastly, I mentioned the CICS bundle Maven and Gradle plugins. So this is here. This is the bundle Maven plugin or Gradle plugin, and this runs on the workstation here. And here we can see we've got your workstation. You've got your Maven plugin here. That talks to Maven Central, and that the purpose of this is to build a zip archive that contains a CICS bundle project. Because if we looked at these previous build files, these build files would just be producing a WAR file. So they'd be packaging in the native WAR format. It wouldn't be creating the CICS bundle format that you may well want for deploying into CICS. So we have an additional plugin which creates the CICS bundle and also can zip it up. And the reason it can zip it up is actually it can integrate with our CICS bundle deployment API, which is a part of CICS Flex SM support, runs in a WUI server or an SMSS standalone server to receive that zip and install that into your CICS system. And so these are new components that have recently been made available that you can use as additional extras on top of your Maven and Gradle build tool chains. Okay, so I think that's probably enough discussion about new technology. I'm sure your heads are all spinning. Just about the last bit I've got, just as a quick plug for the CICS API. So I mentioned this, and this is a new API for Java in CICS. So it's very similar to CICS, but it's got an X on the end. So that it's a variant of CICS, and it's aimed to provide a simple and easier way to use link, but allowing you to support mockable and stubbable frameworks like Mockito, but also something that's remotable. So remotable means that we can run this inside a workstation. So this code could be run inside a Liberty on a workstation, or it could be run inside CICS, and a Liberty in CICS. If you run it on the workstation, you configure a connection to a Liberty in CICS, and then the actual commands that are CICS commands will be shipped across that internal transport and executed in CICS. So it would look a bit like this. We'd have our workstation here. We have our little method here called CICS. We're going to try running this bit of Java. So we're going to create a task, and we're going to do create program linker with channel. So we're going to do a program link with channel, and we're going to link to this program prog, passing in a container with some string data. So when that runs inside the workstation, if you have this feature configured, the CICS client 10, then you'd have configuration telling this component to ship all CICS commands over to this host. That would then be configured in a Liberty server running in the CICS server here. The commands will get shipped across by HTTP. The link program would get executed here, and would then link to our COBOL program to get the container, that would return the container, and the data will be passed back to our workstation. So this enables you to do a very simplified functional testing on your workstation, rapid turnaround of testing using a live connection to a CICS system. So really great bit of function to improve developer productivity. Currently, we only support the link with container APIs and the task API for sync point control. That is something we're looking at increasing the availability of APIs, but that is the main API used by a lot of Java programs in CICS. Okay, so just to finish with a few notes on deployment, and then if we got time, I got a little bit of a demo that I might have a go at showing. So some best practices. So with Spring Boot, the annotation scanning at startup and the class loading can cause a high amount of CPU and I/O. So some key things you need to look at when you move these applications into the enterprise is to optimize your build. Make sure you're removing unnecessary dependencies. You're not putting in, making your application too rich unnecessarily. We've mentioned about not including any runtime components in the build, so don't include CICS or Java EE because they're provided in the runtime. Another big important point is to not place any non-Spring components in the same Java package tree as Spring components. This is because it means those components won't be scanned for annotations. And so that will remove a lot of that annotation scanning burden if you've got a large number of non-Spring components in your package. So you can find out more about this online, but it's a key issue because if you put your Java components in the wrong Java package tree, it could be very difficult or time consuming to remove them from that as you move forwards. From a runtime point of view, you systems programmers, it's very important to look at batching of CICS region startups in this environment. Make sure you try and batch those region startups that are starting up JVMs and applications at startup, so you don't get too much interference between the application starting. You can further serialize application startup in Liberty using inbuilt Liberty support with this starts after ref attribute. However, that does not apply to CICS bundles, only Liberty application elements. So it's of limited use. It can be used. In Liberty, there's a support to prevent the HTTP endpoint starting before the applications are ready. And there's a start timeout parameter that controls that. But again, that's only if you're using application elements. It doesn't work with CICS bundles. That is something that we're looking at to also support for CICS bundles, because CICS bundles use a different install mechanism. A third thing to look at is the use of auto-expand. Auto-expand is a setting that controls how the jar archive is expanding. Some customers have found that the auto-expand of true places unnecessary strain on their ZFS, although in our benchmarks it does give good performance if used, but that is something to look at if you're suffering ZFS performance issues. And lastly, to recommend the latest fixes, this is an area of ongoing investigation and optimization. So we have CICS and Liberty and Java fixes that should be applied across the board to make sure you're getting the best performance at startup time. Okay, so that's everything for my presentation. There's a few charts here about charity raffle, and please submit your feedback. And please become a member of GSE UK, lots of benefits there. That's about everything. So if we've got time, Rob, I'll just switch to do a little demo, if that's okay.
Yeah, sure.
Okay, let's see if we can get this working. Okay. Right, so if we look here, we've got an Eclipse environment, and here we've got a project, Spring Boot JCICS master, and we're running, and this is a Maven build environment. And we can see we've got, this is a POM XML, and this is a copy of the POM XML. So this is something I imported directly from samples. So if we wanted to build that, the typical way is just to do run as Maven build. I've set up a clean install build earlier. We run the clean install build, and then up here in the console, it pops up a little window, and it tells us if the build's running. It does the packaging, and we can see that here we've built the WAR file, and we can see it's gone into our target CICS Java Liberty Spring Boot WAR archive. So it should be in our target directory. So if we go to our target directory here, and we can see we've actually got, if we refresh, we've got a WAR and the old copy of the WAR original. So that WAR file could then be, for instance, exported, and we could export that to ZOS Unix file system using one of the export wizards, or we could add it to a CICS bundle project. So that's using Maven. So if we want to use Gradle, I'm just going to switch workspace to a new workspace using Gradle, and then we're going to pull in a Gradle file. So just wait a minute while that loads. Okay, so here I've got 3 projects, but I'm going to import a new project. So I'm going to import the same one, an existing Gradle project. So I'm going to import our sample, which I've downloaded already, the CICS Java Spring Boot JCICS, into my workspace. And that's going to pull that down. So that's on my workstation at the moment. That's going to pull it into my Eclipse environment and create a Gradle project for me based on the build files that are in there. So that should run quite quickly. Okay, so now we can see we've got this project here. So we can see we have a build Gradle file, and here's a build Gradle file that we've got. And then so to run Gradle, we look here at Gradle task view, and we click on the name of the project, and we can look at the build, what builds are available. We've got various things we can do. So for instance, we can clean the project, and that will delete anything that's lying around. And then we could run the boot war. Remember, we said we were going to build a war. So we run the boot war. So that's building the war. We've got the war plugin available here, we can see. So we can see that's in the console here. Look at the console. We can see that that ran successfully. So if we then look in the build output, we'd see that we've now got the project built successfully. That will be available on the file system. We could then grab that and then export that also to our workstation. If we wanted to extend this, we could add further components into this to build a CICS bundle project, and that could quite easily be done. I'd recommend this tutorial. So there's a tutorial here on github.ibm.com called Extending a Java Application to Produce a CICS Bundle. This goes through the steps that you would then add to your build, Maven or Gradle. And here we can add a few more statements into our build file. If we added these statements, it would then build us a CICS bundle project and also a zip archive for transfer across to CICS. And so that details how to use those CICS Maven and Gradle bundle plugins. I don't think I've got time to demonstrate that because I think I'm rapidly running out of time stealing it from Rob. So we've got 12 minutes left for Rob. So I'm going to stop my demo now. I've chanced my luck enough on demos, and I'm going to hand over to Rob.
Thanks very much, Phil. A lovely technical presentation, unlike mine. I'm just going to try and share my screen, if you'll bear with me, folks. I've got 2 screens on the go, so you're looking at me looking at the other screen. Sorry if it's a ghastly view for you. Yeah, IBM kind of asked me to talk about this a little bit. I think I touched on it at our last GSE, and Phil and I also did some work together for Share, Phil, was it last year?
So, yeah.
Yeah. So it's a customer experience. I'll try and get it full screen for you guys. Hopefully you can all see that. I can see it on my mobile, so hopefully it all goes through. And yeah, we had a bit of a side of the desk proof of concept here going on with CICS and Java, and I'm just going to delve into the reasons as to why we did it, not just for fun, and where we are so far. It's certainly a journey, but so far it's been quite successful. So I'm just trying to share where we are. So I'm going to talk about this, and you may gather as we go through the foils that I know very little about Java in CICS, probably a bit more than someone who's never touched it, but credit where credit's due. Reddy, who works in our team here at NatWest, and Dave Dodd, who's the systems programmer in my team, have done all the hard work and the hard yards. Reddy's done all the work with Maven and all the things that Phil's talked about, preparing a Spring Boot application, both off-host and on-host in CICS, and comparing them. And this is really just a little bit of a play on what we found. But basically, we looked at CICS in Java because we'd run Java elsewhere for new application, and the performance just wasn't good enough. Now, that isn't to say that Java isn't a wonderful language off host and it performs well. Yes, it does. But as with a lot of applications in a large bank, they talk to each other on long pieces of wet string several times, and usually at high volume with a demanding customer response. And what we found was it just didn't perform well enough. Latency was too much. Didn't matter what we tuned. They were just the data, the applications we wanted to talk to, and the application we wanted to run were just too far apart. So we wanted to code in Java. Our developers wanted to code in Java, the customer. And we were using Spring Boot already on a PCF platform. So you mentioned Pivotal, that's Pivotal Cloud Foundry, for those that don't know. And we just ported the Spring Boot application. Spring Boot to me, to Java, is a bit like 4GLs were to COBOL in the old days. It's just a better method for creating all your code that you want to run. And what we found, without stating the obvious, the Java code's running much closer to the date there and other applications it might want to talk to, so it runs faster, a lot faster. But also we found that, I'm not going to say that Java in CICS ran better than off-host, because I didn't want to put it on paper, but it did. It did run better. So at the moment, compared to years ago when some of you might have looked at Java, the improvements are phenomenal, and we're light years ahead of where we were 15, 20 years ago when it first came along, the mainframe. So yeah, we're trying to modernize an application, which is really easy to do if you're running some monoline application somewhere, the data's close to your application, and you can do it quite straightforwardly. But when you want to update an application that's part of an infrastructure or part of an application, it's not so easy. We don't really want to re-engineer COBOL so much anymore. We'd like to write it in the language that our developers know and understand and can do quickly. But we're a very, very demanding customer. We want to do thousands of transactions a second, and we want to do them very, very fast. So that's basically reading out what I just said on that slide there. Times. What we saw with the off-host application was responses between 3 seconds and half a second for high volume systems in the future. It's not going to work. It's not acceptable. And we've ported the application, which is pretty easy to do. And the times we're getting are less than 100 milliseconds for the same application, exactly the same code. And that's only on a Sandpit mainframe, our SPLEX here at NatWest, which is nowhere near as powerful as even our development boxes, let alone production. So I do expect the times that we're going to show you a couple of foils to improve in production and when we get into serious testing. These are the results really from our sort of side of the desk setup. Here's a typical setup. I've nicked this slide from somebody and renamed all the LPARs in the CICS regions to protect the innocent. I even changed the port numbers and TCP/IP addresses. What is it like in the CICS region? well, we're running some JVMs, LE enclaves that you might be familiar with, the JVMs not so much, but there are SIP profiles and SIP palms that you're familiar with in CICS that you can change to configure these, and that's just kind of how it hangs together. So Spring Boot is running within these JVMs, within LE, within a CICS region, and that's just kind of how we're managing it with Liberty and everything else. This is the sample microservices application that we did. These are test names, so I haven't had to change these, thank goodness. But we're carrying out a multitude of mainframe services as part of one overall service, which I suspect if you're running any sort of banking type services, you might be doing that yourselves. So it's a typical real world application that we were trying out. And here's just some of the results taken from one of our monitoring systems. What we've got here is a kind of parent transaction and some subset transactions underneath. So the overall response time and lifetime for this top transaction, JDB0, is the overall lifetime of our end-to-end transaction, and these other transactions underneath are kind of like spawned and carrying out various services for the parent transaction. I hope I've explained that correctly, Phil.
Well, sounds good.
Just a few notes and gotchas. Like I say, I wasn't doing this myself, but we tried out two JDBC calls, type 2 and type 4, which are the main ones. Type 2, I'll loosely describe as DB2 Classic. It uses less zips, but we also found during our trial it used less MVSCP as well. Type 4 is more generic and there's more zip eligibility there, but it's more networky in what it does, so possibly less efficient than the classic one. We've done everything on a CICS 5.4 system, which as Phil alluded to in some of his notes there. We're working with WAR files rather than jars. We're going to upgrade to CICS Next, Vulkan release, or 6.1 if we're allowed to say that. I'm not from IBM, so I guess I am. Which is coming out maybe in the middle of next year, who knows. I'm sure IBM will announce it eventually. Security was interesting. Security is interesting off-host and on-host with any kind of Spring Boot application that gets deployed. There were a few gotchas, and I know Phil helped us, but there wasn't, once we understood it, there wasn't a lot of fiddling that we had to do to make it work. It's just maybe some of the docos not spot on. But if anybody does entail on doing this, we're certainly going to progress with this. I'm quite happy to share information in the spirit of GSE on request. I did touch on Spring Boot earlier on when I was rambling. Yeah, it just got that feeling like just makes writing Java programs easier. A bit like a 4GL made writing COBOL programs easier, I guess. Sorry, I'm always one for giving analogies. Certainly with any Java application and the way they work, there's a lot of caching under the covers. The application actually has to start up and warm up before you start getting your normal response times. That was an interesting one to me. And I guess it's sort of seconds, maybe minutes, rather than microseconds for an application to warm up. Also, if you're deploying things via bundles, operationally, I think we're going to do some more testing. I'll touch on that in a second, and a bit more thinking about how we're going to manage this operationally. So we finished an unofficial trial, but it's been so successful, the results have been presented. And really, for the problem that we're looking at, there aren't a lot of alternatives. Maybe moving all the data or all the other applications to be next to your application off host. But that does seem like a very large undertaking. I know there are some data copying type techniques that are out there now with things like Kafka that are available. But really, if we're going to run what we want to run, how we want to run it, and leave our other applications where they are at the moment, we don't have a lot of choices. It's surprisingly simple to move a Spring Boot application onto the mainframe if you know what you're at. And we're very lucky with having people of the caliber of Reddy and Dave involved in POC. Yeah, we've got an official sponsored trial, we've got a budget, we've got PMs, and we'll be moving this forward out of the sandpit onto our development boxes, trying out all the operational issues, like what happens when something breaks, how do you fix it, do you restart the CICS region, do we run things in separate CICS regions? Yes, is the short answer at the moment for us. I think that's better than running a mixed workload of COBOL and Java in the same environments. There are a lot of sit palms that are different, but that's just my take on it at the moment. I'm sure it's all possible to run together. I think the main thing is just running CICS regions on the same LPA, keeping that closely coupled vibe throughout the whole thing. And I guess that's time, so I'm finished. Any questions?
Hey, thanks, Rob. Thanks, Phil. No questions in the chat as yet. If anyone wishes to ask a question, either put it in the chat or put your hand up. Otherwise, we are over time. I am aware that there's a lunch and learn running at the moment, which is to do with home network security by Jamie Pease. So if people want to attend that, they can, obviously. Please send your feedback in on this session, and we will be back again next week, I think, Rob.
Yeah, 9 o'clock on Tuesday. It's Pradeep from Hersley, and I can't remember. I didn't write down what it was, and I haven't got my. I'm screen sharing now.
Yeah, resources.
It's something to do with resources. Excellent. But yeah, so see you all. If you can give feedback via the normal channels, I always forget to mention that at the end. That would be great. And good luck with your Java journeys. Cheers, everyone. Thanks for your time.
No questions, so I'll end the session.
All right.
Thank you.
Cheers,
Thanks,
Nick.
Rob.
Cheers, Phil. Thanks very much, Phil.